to this data division and get them started.
That's perfect. This meeting is being recorded.
Welcome back, everyone, to COBOL Fridays. Um, Today, we have Dr. David Wilbright from Columbus State University to talk about, the data division, more specifically, data types, and how can we do handling of variables? What is unique to COBOL in how it handles variables and data type definitions? So without any further ado, I'm going to let Dr. David Wilbright take it away. Thank you, Dr. Wilbright, for being here with us today.
Thank you. I appreciate being here. I am David Woolbright from Columbus State University. I'm retired now. I run a blog site for some of my training materials on punctiliousprogrammer.com. It's a lot of assembler and COBOL materials. Today's talk is called Starting the Data Division. It's aimed at beginning programmers who are starting out on mainframe. I thought this picture would be helpful as you think about writing a program and how it's treated by the operating system. Essentially, you have a COBOL program that is carved out a region and your program runs in that region. You're not the only thing in the region. If your program was a subroutine, it might have been called by another program, or could have been called by the operating system, kind of like a subroutine. There are I/O buffers in the region. Your program wants to read data, so the data exists on a disk somewhere. There's large I/O buffers. It can be hundreds of these things. Uh, so there's data that exists in these buffers we need to address. There's data that's being passed to you by a calling program. And in today's COBOL, you can allocate space dynamically. Back up. Sorry about that. You can allocate space dynamically and ask for dynamic storage on the fly. So there's more storage that you might need to address. And that's what you do in the data division. There's three divisions, or three sections in a division. There's a working storage section, and you use that to describe all the data that you're and variables that belong inside your program. Along with that, you get a file section, and that defines all the files that are on the disk and all the record structures that you get in these I/O buffers that um, bring your data in. And then finally, there's a linkage section where you can define all the variables, excuse me, for data that's passed to you or that's dynamically allocated. So there's three different sections that we're going to talk about. And this is a good picture to have in your head for how it all relates to each other. So we'll start these three sections. The file section is for defining files and the record structures that are in these files. These mainframes are really sophisticated and they're designed to pump data at you. And the methods they use are quite sophisticated. There's lots of access methods, lots of different types of files. If you haven't programmed on a mainframe much, then you should be aware that mainframe I/O is record. I'm having trouble here. Hang on. There we go. Mainframe I/O is record oriented. It's not field oriented, sort of like Java. In Java, you're asking, give me the next field, give me the next field. But typically in mainframe programming, you're asking for records at a time. So I'll have some tips along the way. As you're learning to do I/O in COBOL, you want to read a file and write a record. That's kind of an old mantra. Anytime you want to access a file for input, you're going to name the file name. But if you're trying to produce output, you have to name the file record. So the mantra is read a file, write a record. Let's have a second tip, and that's you might want to avoid read intos and write froms. There's a couple of ways you can do input on the mainframe, locate mode and move mode. And there's sort of a performance hit, and it's pretty substantial when you start doing read intos and write froms. That's all I'll say about that. Let's move on. Here's an example of what you would see in a file section. This is simplified. There's lots more that we obviously won't talk about, but basically you give it a file name and you give it a picture of your record. I have two files, an FD for the customer file and an FD for a sales report, and I have two records. So there's my There's my file section. My tip is don't reference these fields. Don't touch or try to modify or read these fields before you open the file or after you close the file. Because these are the areas that are referencing those buffers. And it only makes sense to touch these fields if the file is still open. Move on to the linkage section. That's the second section we'll look at. It's used to describe fields that are outside of your program. In other words, the data that's being passed to you by other programs, or data that might exist in dynamically acquired storage. You may not own the storage for this. The mouse is killing me. Sorry, I keep flipping screens. Well, I'll get better, hopefully. You may not own the storage for this thing. There used to be very strict rules about the linkage section and what you could use to use it for, but those rules have been loosened as the versions have gone by. So if you're coming back to COBOL, having programmed it years ago, you may find that you can do more with the linkage section than you could before. We can now use it to manipulate areas that are dynamically acquired by using pointers. So that may be a feature you haven't used before if you programmed quite a while back. We can exploit this feature to build modern data structures. So if you're interested in data structures like stacks and queues, this is how you would do it in COBOL. Here's a linkage section example. Perhaps a program's wanting to pass a couple of parameters to me. I lump them together in one big parameter called name age. In the procedure division, the program would look like this. It would say procedure division using name age. I would name this linkage section area in my program, realizing that this is the data that's going to be passed to me from a separate program. All right, we're going to move pretty quickly through these. We're not stopping for too many details, but I'm trying to give you, just orient you to how this stuff fits together. The working storage is where you define all the fields in your program. There's about 4 different elementary types: numeric, alphanumeric, alphabetic, which is quite old, and a newer type called national. Alphabetic has pretty much been subsumed by alphanumeric. Alphabetic was just for data that was letters of the alphabet and a blank. So pretty much we can do all of that with alphanumeric. So if you're just starting out in COBOL, this is pretty much what the data looks like. It looks like numeric data or alphanumeric data. Data in COBOL is hierarchical, just like XML. If you're familiar with XML, the data structures are hierarchical. That matches perfectly with COBOL, and that's why COBOL is a great language for processing XML. There's several statements that you can use to process XML easily in COBOL. When we're describing COBOL, we'll use level numbers, in particular 0, 1 through 49, as indicating what this hierarchy looks like and which fields are subordinate. So we'll talk about this in more detail. As we go through this, if there are questions, feel free to stop me. We'll stop, just as we would in a regular class. Otherwise, I'm going to keep plowing through this, but if there are questions, feel free to ask. So we've got these level numbers. Let's move forward. The level numbers are at the front of the field definitions. So this is an example of a typical working storage section. We have an O1 called customer count. It's a packed decimal field with 3 digits and a sign. This is an independent item because it's not subdivided. There's no fields underneath it. And it's called an independent item in COBOL. This particular field is a group item because it is subdivided into subfields. And there's a hierarchy here that's indicated by these level numbers. As you get higher numbers, you're going deeper into the hierarchy. Like in all programming languages, a variable is a storage area with a name and a type. And we get the same idea going on in COBOL. So variables are or data fields or data names or data items are essentially variables, storage areas with names and types. The type determines the type of information that can go in the field and the type of operation that you can apply to the field. As we said before, there are elementary items. Oops, let me back up, sorry. There are elementary items, that would be a single field. There are group items, that would be a field that contains others. So part number here is a group, whereas part name and part number are elementary items. Let's get back to the level numbers. They run from 01 to 49. Only 01 has a specific meaning. If you label something 01, it has to be at the top level of the hierarchy. And that makes it either a group item that has something underneath it, or it's an independent item off by itself. The specific numbers you choose doesn't really matter. What matters is the relation of the numbers to each other. As you go higher, we're going deeper into the hierarchy. Some companies have standards about the types of level numbers you choose, and so 3 and 5 are common increments.
Dr. Wilbright,
Yes.
one question here about the sections in the data division. What about local storage section in data division is the question.
There is a local storage. So as I said, I'm trying to aim this at beginners, and so I've omitted local storage from this discussion. But I can refer you to the language manuals for that. Is that okay?
Yes, sounds good. Thank you.
Okay, so there's a lot there's a lot that's going to be left out. Trying to highlight just the things that perhaps you would see in a typical business program, uh, especially those and programs that that beginners might write. All right, so we've got group items, elementary items, this O1, which can either be a group or an independent item. And so here's an example. We've got customer table. It's at the top of the hierarchy, and it contains a 110 level item, which is called custom rec. That occurs a bunch of times. So this is actually a table. So this customer record is occurring 100 times. This is driving me nuts. Sorry, my mouse is active. Underneath that, every customer record consists of a customer name and a customer balance. Within customer name, you get last and first names. These two are independent items, though. They're not subdivided. That brings us to the special level numbers. There are 3, 66, 77, and 88 that have special significance. Personally, I never use 66. I've always thought it was a bad idea, but that is just my humble opinion, all right? So I would advise, especially if you're starting out in COBOL, not to use 66. It's for restructuring a field that already exists. And I would advise not using it. 77s were the original way that you could create an independent item. That restriction is loosened in COBOL, and now you can use O1s or 77s. Personally, I have switched over to using O1s always for independent items, but other programmers would have different opinions about that. 88, though, is an important condition, and we'll talk about it in more detail in just a little bit. So those are the 3 special level numbers. When you're declaring something, there's 5 parts that you can write down. You can put a level number. You can add the variable name. Won't go into all the details of naming variables. That's something you could look up, but any reasonable names will probably work. There's a picture clause that indicates the size of the field and whether it's numeric or alphanumeric and whether it has a sign or not. There's a usage clause. The usage clause determines the internal data type. Is it a packed decimal field? Is it binary? Is it alphanumeric? And finally, you can give it a value. Those are the 5 parts of every declaration. You can omit things. You don't have to code all 5 parts, but every field has to have a level number, right? can't get away without a level number. So that's a requirement. And my only tip is, if you're a beginner, use indentation to highlight this hierarchy. You want the program structure, physical structure, to reflect the logical structure as well. You can omit the name of a field, as I've done here. If your program is never going to touch the field directly, you can leave the name off, or you can give it a name filler. That's the traditional way of creating an unnamed field in COBOL. In both cases, this is an unnamed field. I kind of prefer the first because it sort of makes the program look a little lighter if you're looking at it as a whole. But that's a matter of style. Every elementary field must have a picture. You cannot omit the picture clause. That tells the compiler how big this field is and whether it's numeric or alphanumeric. You can omit the usage clause. That's a little unusual, and I don't know of any other language that allows that. The usage clause would either be this one, packed decimal, or you can spell it out and say usage is packed decimal. That's where you're telling it the data type that you want. It's a packed decimal field. It's a binary field. In COBOL, you can leave it off. There's a default. And the default for this type of field, numeric fields, is called zone decimal. We'll talk about that some more. So it is possible to leave off the usage clause. I don't recommend that, though. I would prefer to go ahead and let's make a decision and not take a default. You can also leave off the words usage is. That's just noise to the COBOL compiler. We're still talking about what can you omit when you define these fields. Well, group clauses never have explicit pictures. In other words, you never put a picture on a group. That's because it has an implicit picture. And the implicit picture is always picture X, and it's equal to the size of all the subordinate fields. So this is a 20-byte field, an 8-byte field. This one's in packed decimal. You'd have to know a little something about packed decimal here to be able to figure out how big this field is. I'll tell you quickly, it's 5 digits in front, 2 digits behind the implied decimal point. That's 7 digits plus a sign. And in packed decimal, you pack 2 items per byte. So this is 8 things we need to put in a field, right? 7 digits plus a sign, and divided by 2 would be a 4-byte field. So this whole thing is going to be 32 bytes. One of the things you need to do if you're starting out in COBOL is learn some of the mainframe data types like packed decimal or zone decimal or binary. And we'll talk a little more about that. So that's my tip. Get your nose in a book and learn a little bit about the mainframe data types. It's important that we be able to know the exact lengths of some of these fields. Sometimes it's not obvious. To a beginner, that might look like, what, 5, 6, 7, 8 bytes, but it's actually a 4-byte field. The other tip I would give you is that any definitions that you code in the file definition have to be exact, right? You've got to be able to describe your data exactly. If it's off, your whole program will be in error. There's a little more leeway in working storage, right? There's a little more leeway in working storage. The compiler is generous if you make certain wrong decisions. And that's all I'll say at this point about that. What else can we omit? We can omit the value clause. If you omit the value clause in a declaration, then the field is uninitialized. It is possible, if a program is called multiple times, that the variables you've initialized can be reinitialized every time you call a program, or not. You have a choice there. And for people that have coded a bit longer, I'll just mention that you can read about the initial phrase in the identification for that feature. All right. Here's this slide gets at what happens when you define things sequentially. I apologize for all the movement of data. I'm not sure why my mouse is doing that. Let me get, sorry, going the wrong way. Hang on. There we go. Try to be a little more careful. When we're defining things sequentially, they typically end up sequentially organized in storage. So if you define part name and part number sequentially in this definition, they will be physically sequential in memory as well. There's one exception to that, and that's for binary fields that are synchronized or properly aligned. Occasionally, the compiler will generate a few slack bytes between fields in order to get a binary field properly initialized. All right, we're finally getting back to these condition names. This is a feature that I think is, not sure you can find this feature in another language in quite the same fashion. Uh, but you can use this idea to make your programs a little more readable. The idea is if you had a field like transcode, just a simple single byte field, picture X, you can give a condition name, good code, to the condition of transcode having the value of G. So this 88 level says this is a condition, and the condition is equivalent to transcode having the value G. Bad code is equivalent to transcode being B, and indifferent is the condition transcode being I. We can use these condition names in various ways. And for instance, I can say set good code to true, and that has the effect of moving a G into the transcode. But in a sense, this is sort of better documentation. It's getting closer to what I'm actually trying to accomplish rather than just moving a value to a flag somewhere. I can also test these condition codes. So I can say if good code, and that would be equivalent to uh, writing an if statement, if transcode equals G. And the beginner tip I have here is you can't set a condition code to false. Why would that be? Well, if transcode is false, we know it's not G, but we wouldn't be quite sure whether it was B or I if we allowed condition codes to be set to false. So you can only set a condition code to true, and you can test it with an if statement. If you use these things well, you can do things that are a little more complex. For instance, you can have conditions that are a little more complicated. Values are 0 through 12 for child, or values are 13 through 19 for teen, and values 20 through 120 for adult. And then you can test them. You can say if teen, if adult, if child. The nice thing about writing like this is it's sort of self-documenting, and it's easy to modify. For instance, if you decide, if conditions change and you decide that 18 is now, or 19 is now an adult, you can just simply change your condition, and the actual logic of your program doesn't have to be altered at all. So that's a good thing. On the other hand, it can be a bad thing. I have seen programs where if you choose the wrong condition names, it makes the program harder to read. So like all features in all languages, things can be well used or not. The picture clauses end up being built with these characters: nines for digits, X's for alphanumeric, V for an implied decimal point. It's interesting that the arithmetic, internal arithmetic on this machine does not contain decimal points. If you're doing decimal arithmetic, the actual decimals don't exist in memory. So that's why we're using a V for implied. I'll talk a little more about that because that's kind of a beginner's mistake in some cases. S is used for signs. You can use an A for the letters of the alphabet, but typically I think this has sort of fallen out of use. These are some just some quick examples of pictures that you could code. The parentheses are repetition factors. These two are equivalent. That's about all I'll say about it. This one pokes out at me, jumps out at me because of it's lacking a sign. And that is sometimes a beginner's error that we'll talk about as well. If you start using symbols like these, a B for a blank, a slash, asterisk, period, minus signs, credit or debit, dollar signs, once you start mixing these symbols in, you're getting into the realm of edited fields. So if any of your pictures have these symbols, you should be editing. The idea is that these fields that you're building are really for printing and not for arithmetic. And we can, in fact, do some arithmetic with fields like this, but that's sort of an advanced topic. So I'm not going to get into that. If as starting out in COBOL, if you're using these symbols in your edits, you should be thinking these fields as fields I need to print on a page. This is this slide highlights the distinction between fields that are used for arithmetic and fields that are designed for printing. So if you define a field as S999, V99, packed decimal, you're intending to do arithmetic. Anytime you use a V, there's an implied decimal point there. And the field is supposed to be used for arithmetic operations. Once you put a period in, though, that's a numeric edited field. You should use it to be for printing. It would be fine to do your arithmetic with X and then move it to Y where it could be printed, but you don't want to be trying to do arithmetic with numeric edited fields. And that's a common beginning error. I'll stop there for a second just to see if there are any questions that we need to think about.
So there was one question when you were talking about level numbers. The question was, why does a level number from 1 jump to 5, for instance, when you were, talking at the next level? What about 2 to 4? Is there any reason that's not used, or is it used?
It's somewhat arbitrary, but the idea is if you jump from 1 to 5, if you have to go back and rework this hierarchy, you can insert a lower level number between 1 and 5, right, on the fly. So the level numbers are somewhat arbitrary, but there usually is some distance between them just to allow for future additions if necessary.
All right, got it. Thank you.
All right, there's some data types. If you're starting out on the mainframe, there's some data types you need to learn about. I'm not going to get into all the details of these types, but just to ask you to look them up and take a look at their internal structures. Or my mouse is trigger happy. So zone decimal, packed decimal, and binary. Most business arithmetic, 95% of all business arithmetic occurs at the packed decimal level. If you're in binary, that's a fine format for counting. If you want to count the number of customers you're processing, if you want to measure how many bytes it is from one variable to another, binary is fine. Zone decimal is a funny format. We'll talk about it in a minute. I will mention hexadecimal just for the beginners and only briefly. We're going to use hexadecimal in the future slides here just as a shorthand. So again, base 16 is hexadecimal. After you run out of digits, 9, we invent more digits, A through F, or 10 through 15. And the way we'll use it just briefly is this. If you have a binary collection of bits, we can, let's say this is a byte, 8 bits. We can divide it in half into two 4-bit segments, and we can use one of these hexadecimal digits to represent each segment. So instead of looking at a bunch of ones and zeros all day, we can look at a bunch of hexadecimal digits all day. It's a little easier to do that. So 1011 is 1, 2, no 4s and an 8. That's an 11, which is a B. So essentially, you're just substituting hex digits in for binary patterns. And where do we do that? Well, we can do that in EBCDIC. EBCDIC is an encoding sequence for characters. We want to be able to store the letter A in memory. How can I do it? I can do it as a binary pattern, C1. Right? So there is a kind of a method in this madness of EBCDIC. The first block of letters, A through I, are in sequence as far as hexadecimal numbers, C1 through C9. And my tip here is you should learn a few letters and digits in EBCDIC. Not asking you to memorize an EBCDIC table, but it's helpful to be able to recognize at least the letters and digits. So let's take a real quick look at the letters, C1 through C9. D1 through D9 is the middle block. A mnemonic is junior, JR, right? So D1 through D9. There's only 8 more letters, so we either have to leave off the first one or the last one. IBM chose the first one, so that's E2 through E9. So there's very quickly, the letters are easy to learn in EBCDIC. So are the digits, F0 through F9. There's a handful of others that would be helpful to know. Space is 40, period is a 4B, 6B for comma, 5C, and 60 for a minus. So as a beginner, just take a quick look at EBCDIC and memorize a few of the symbols. It helps if you have to look at a storage dump. So here's my pop quiz. Here's a field I've defined: balance, pick X7 value ABC. What does it look like in memory? It looks like that, right? It's a 7-byte field. C1, C2, C3 for A, B, and C. There's a 40 for the blank, and F1, F2, F3. So there's what's in memory based on the EBCDIC coding sequence. This is the saddest slide I'm going to present. I'm old enough to have punch cards. It's a sad fact. But true. I was a youngster, but a youngster in college, unfortunately. And punching, what I didn't realize was by punching cards, where I was actually producing what's called zone decimal data. And the other thing I didn't know at that time was that COBOL will produce zone decimal data if you have a numeric field in which you omit the usage clause. In other words, you don't declare it. Here's an example right here. You don't declare it to be binary. You don't declare it to be packed decimal or comp3 or any of the other possibilities. If you don't specify, you get zone decimal by default. And let me describe my experience teaching or punching cards here. Let me get back to it. Whenever I punch cards, if you were going to punch a 1, 2, 3, you would sit down in the machine, stick some cards in the machine. It would feed over the first card, and you'd type a 1, and then you'd type a 2. But when you got to the 3, if this was a negative field, you would have to use 2 fingers. You'd have to find the negative key and press it down, and then press the 3. And the negative sign was encoded on the last digit. And that technically is zone decimal data. If you typed this field, it's going to look like this in memory. You'll see an F1, that was the 1 I typed. The F2 was the 2, but it's inserted a sign in the zone portion of the last byte. And this format is a direct result of people punching cards so many years ago. It's usually not the best idea, not the best format to be in COBOL, but you can accidentally get there if you forget the usage clause, as I did in this one up here. So technically this is a display field, but you wouldn't be happy printing it. If you print this field, this will print as a 1, that'll print as a 2, and a D3 is an L in EBCDIC. So even though it's called a display field, it's not, you won't be happy displaying it. So you can do arithmetic in this format. The COBOL compiler is very generous. If you get a zone decimal field, it will convert it for you without telling you. So that's one thing that COBOL does, is it's very generous in the field definitions. It's willing to make numerous data changes in order to make the arithmetic work out for you. Here's just a few others. Just a -1 would end up being, with 3 digits, would end up being F0, F0, D1. There's the negative sign. If it was positive, you would end up with a positive sign in the last byte. If you forget the sign here, that's usually not a good idea, because COBOL will make efforts to ensure that the sign ends up being positive. So my tips are, Don't forget to code your S's on these numeric fields. You usually want them there. And try to avoid zone decimal if possible. There is this idea of binary fields. You can do arithmetic in binary. Most business arithmetic doesn't occur in binary because when you convert from binary to decimal, there's all sorts of round off errors you get. So accountants get antsy when you start losing pennies. So most business arithmetic occurs in packed decimal. And this machine is very sophisticated and is capable of doing floating point arithmetic. Not only can it do floating point, it can do it in binary and hexadecimal and even decimal floating point. So it turns out that if you work in packed decimal, the compiler may decide to optimize your code and actually use some floating point decimal in the background. And that may be something that an older time COBOL programmer might not be aware of, but it can happen. So there's a little bit about binary. Here's my beginner's tip. If the calculation involves implied decimal points, we need to be in packed decimal because you're going to get round-off errors moving from binary to decimal. The weights are completely different, right? The weights in decimal are all powers of 10, and the weights in binary are all powers of 2, and they're just some things you can make in one base that you can't make in the other if if you have a fixed number of weights. So my beginner's tip is to use packed decimal. I'm about out of time. Should we go on or should I clip through this? I'll
No,
ask
you
you.
go on, Dr. Wilbright. This is great. Yeah.
All right, all right. Well, there's not much more. We're almost at the end. This is probably the most important data type you would use as a COBOL business programmer. It's packed decimal. It's also called computational 3. That's an older name for it. Or comp3 is also the name for it. Basically, I'm not going into all the details, but you get 2 digits per byte and a sign stored in this format. So a negative 23 would actually look like this, 0, 2, 3, and a sign at the end. There's always an odd number of digits, no matter what kind of picture you put out here. Internally, there will always be an odd number of digits because we always have a sign at the end. So that's a little bit about packed decimal. Most packed decimal, most business arithmetic occurs in packed decimal. Just quickly, there's a rule about figuring out the size of these. If you're defining what your input looks like, you have to know exactly how many bytes are in it. So a field like this has 5 digits in front of the implied decimal, 2 digits behind. That's 7 digits in all, plus the sign. That makes 8 things. And so we know we're packing 2 things to a byte. That would be a 4-byte field. So I'll quickly move on to this. These are the old type names you would see in some older COBOL programs and even modern programs. Computational, comp, those are names for binary data. Comp1 and Comp2, you rarely see those in older COBOL programs. Those were floating point. That was usually binary floating point, so it was for 2 reasons why you might not want to be in that. Comp3 is a very common type that you will see, but it's equivalent to packed decimal. And I've gotten it into the habit of using this name instead. So these are the names I use these days. These are sort of older definitions for the same thing. If you're just starting out, think binary or packed decimal. That's my recommendation for that. There's some relationships in these 3 data types. Remember when I was typing, punching cards? It's about as low as you can get on the totem pole is to be punch cards. And the data ends up kind of at the lowest level in this hierarchy. If you're in zone decimal, you can switch to packed. There are conversions of the data that will carry you into packed and back. If you're in packed, you can move into binary from there and back. But this packed decimal is sort of in the middle of things. It's and particularly in the middle of all business arithmetic. Working here is mostly where we want to be. I will only just briefly mention this. If you're working in a company, you may run into a company that has what's called packed no-sign data. That is a non-native data type. And the idea was we would take a date and store it in a packed format. Well, if you take this date as just a big number and store it here, you end up with a 0 at the front and a sign at the end. You end up with a 0 always at the front because there's always an even number of digits in a date, and every packed number has an odd number of digits. So someone had the bright idea, okay, we can pack the date and then get rid of the 0 and get rid of the sign and end up looking like this. And you can do that in COBOL, but it takes some special handling to do that. And that means every time you want to reference a date, you have to do some arithmetic. So maybe this was a bad idea in hindsight. It does have the effect of reducing dates by 1 byte. There's something to be said for that. But if your company has this kind of data, you have to deal with it, and you have to deal with it programmatically. If there's time, I'll just do a couple more things and let it go. Cannot do this sort of thing in many languages. I'll redefines. Here I've defined a field, pick x, ZZ99 with a decimal point and negative sign. That's 1, 2, 3, 4, 5, 6 bytes. I come back right underneath, I say amount x redefines amount. I'm going to give it a completely different picture. So what we've done is taken a variable and given it two different, completely different pictures. You could not get away with that in Java, which is a more strongly typed language, and would get upset if you tried to give the same storage area two sort of different pictures like that. But you can do that in COBOL. It's always a neat thing, and it has lots of uses. In particular, I use it this way. There's this idea of pointers now in COBOL that's fairly new on the COBOL scene. A pointer is an address. It's a 4-byte address, but the COBOL compiler does not want you to print it. In other words, you can't display these things directly. COBOL doesn't like that. So what I'll do is I'll take a pointer and redefine it as a binary full word, and then I can print it, and then I can see the address. So there is a use for redefines, and you can use it in some fairly interesting ways. There are no constants in COBOL. That's all I'm going to say about this. You can define a value for a field, but there's no way to make it constant. Everything can change. There are a few figurative constants, 0, space, high values, low values, quote. You can set a pointer to null. All is an interesting word. Technically, it's not a figurative concept, but you can use it in an interesting way. You can say, I want a 50-byte field with all three. So instead of having to type out 53s, I can just use the word all. Let me just show you briefly a table. We'll let this almost be the last slide. Here's a quick table, 15-byte field with these letters in it. I come back and do a redefines on top of it with an occurs. So my redefines is for a picture 3 field that occurs 5 times. So I'm chopping this thing up into 5 parts, and that gives me the ability to treat this as a table. COBOL programmers call them tables. Everybody else in the world calls them arrays. You can use arrays in COBOL. The one big difference in COBOL tables or arrays is that everything starts off at 1, just like your kindergarten teacher told you to count. Start at 1 and go forward. And that's what COBOL does. So moving month 3 here would grab March. So COBOL tables are 1 base. Subscripts can be any integer type. This is a good choice for subscripts. There is also this thing called indexes. I'm not going to get into that. If you really want to maximize the efficiency of your arrays or tables. Here's a Sudoku array. The last thing I'm going to say about tables is one thing I love about COBOL is it gives you so many ways to go after the data. If I use the word Sudoku table here, I get the whole table. If I use the word Sudoku row, I can access an entire row. If I use the word cell, I can get at an individual cell. So it gives you lots of names for processing tables. And that's about it. I think that's the end of the talk.
Wow, that was a lot of detail here, Dr. Wilbright. Thank you so much.
It wasn't too much. If it was, you can go back and look at the slides. You can go back to my
It,
uh,
it you
blog
did a
site for.
fantastic job just talking about all of these and explaining it in so much great detail and differentiating why. And those beginner tips were just awesome. Thank you. Thank you so much, Dr. Wilbright.
Thank you. It was a lot of fun. Thanks for having me on.
Yeah, I do have one question. Hang on, I was just looking at it. Oh, yes. Can Dr. Wilbright explain why zoned decimal is a bad choice? The default?
Let's say you define a field as zone decimal and you give it a value, and then you start doing arithmetic. It will work. The COBOL compiler will accept it and take it, but underneath it's having to do those conversions. Remember, where if you oops here if you start out in zoned and you want to do arithmetic, the COBOL compiler is going to have to convert that data into packed. You cannot print this data. So I guess just from, I'm an old assembler programmer. I try to be in the right data type if I can. So zone decimal is not really a good arithmetic type. You can't do arithmetic at this level. In order to accomplish arithmetic, it's got to be converted to packed. That would be my reasoning. Sometimes you may not have a choice. Maybe the data comes to you in a zone format, but that's a kind of a rare thing. Most business arithmetic is in this format.
Awesome, thank you. Another question is, can you explain numeric edited fields with an example?
Sure. Let me back up.
Yeah, okay, thank you.
And I forget where they were. There. So
Yeah.
for instance, suppose you want this one here is a alphanumeric edited field, right? These are for letters or digits. So maybe you move a social security into here. If you do, these two spaces will end up being blank. Or if you move a date, you move a numeric date into this field, you'll end up with slashes in it. Or this particular field, you will end up zero suppressing the leading zeros. They won't be printed, neither will the comma. If, let's say, the amount was $1.29 negative, you would end up with blank, 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 1.29 debit, right? If the field was positive, the debit would disappear. So the edit symbols are for for doing making the data look good when it gets printed. There's a floating minus sign, or this is a check protect symbol to make sure nobody can come back and change the amount on the check, or a floating dollar sign. There's a lot I have left out here. There's a lot to this. This is one place where you really need to put your nose in the manual and just look at a lot of different programs to see how people are editing. It's not really for a short talk.
Sure. Yeah, that would be great, Scott. Yeah.
Don't have any books. I have a blog site, and there is a video course, a COBOL video course on there, complete with exercises you can try. It was designed, I did it a number of years ago for a company, so it's organized around 5 days of work, 8 hours a day. There's a lot of material there, and you can find it on that blog site. Um, this is this word here, good code, we've defined it as an 88. That makes it a condition. And the condition it defines is this one, that the trend code has a value in it of G. If that condition exists, it is equivalent to this, the COBOL compiler equates that to this um, word, good code. So there's nothing like this in any other language. That's why I think people stumble over it at first because it's not really like anything else in another language. The ability to assign a name to a condition, right? We think names belong to variables, values, but here we're giving a name to a condition, and the condition is transcode has a value of G. Transcode equals G. Here it is, right there. Transcode equals G is equivalent to this word, good code. And I can use that in an if statement, or I can do a set statement on it to make this condition become true. It's a powerful feature, and when you use it in conjunction with other aspects of the language, you can make the language really readable.
All right. I'm just going to look for maybe one last question, Dr. Wilbright, and then,
Hey, I've got one opinion I'd like to give before this is all over.
yes, please.
Is this a good time?
Yes, absolutely. Please do share.
Let me go down here. I've got one more slide somewhere. Oops, went the wrong way. Sorry. I'll get there in a minute. There. These are some of the things that have happened in my lifetime to COBOL. This is not Grace Hopper's COBOL. It's not even your mother's COBOL, right? This is a very powerful language, and all of these features are transformative in how we write COBOL today. Just these two features, the fact that we have inline performs and delimiters, completely revises the way COBOL programs should look. The loosening of the rules in the linkage section, the fact that we have pointers and we can allocate memory on the fly. There's lots of new statements for flow of control and logic. You should look at evaluate. That is the most interesting statement in almost any language going, especially any switch statement. This is kind of an amazing statement called evaluate that's for making logical decisions. We can do XML. There's this idea of nested support and nested programs, very interesting. And we can also do object orientation. What we need are younger people with different ideas and who are willing to reimagine how COBOL programs should be written. That's my opinion. Storing numbers. If you want to Oh, zone decimal. The reason you have zone decimal is just to store numeric numbers. And it's really a throwback to punch cards. It was a data type that existed to accommodate punch card input. And we still have it today. That's why I think we should try and avoid it if possible. It's not a very efficient type to use. You can't do arithmetic in it. So about all it's good for is storing numbers in. And it doesn't really do a very good job of that because it stores one digit per byte. At least if we get it into packed, we'll have 2 digits per byte. So it's not a format you want to use much of. Sure.
All right. We're just about at the top of the hour. Thank you again so much, Dr. Wilbright. I mean, the comments have been on the chat line have also been very thankful. The details that you walked them through, they found it very helpful. So I think this has just been great to be able to really walk us through in detail and also be able to explain the differences. That was very nicely done. Really appreciate you sharing all this immense knowledge with us here this morning, Dr. Woolbright. Thank you
Thank
so
you. I
much.
just love what y'all are doing with this project. I've had so much fun watching and participating.
Thank you. Thank you. And we're looking forward to having access to this deck. I think you said you would be able to put that out on your blog, and we'll link out to it along with the replay.
All right, I'll do that.
That'd be great. Yes. Thank you so much. And thanks everyone for joining us here for yet another COBOL Friday. We will see you again next Friday, same time. And the details will be in our COBOL Resource Hub page that I've been pointing everyone to. So thank you again. Have a wonderful Friday and enjoy your weekend. Stay safe, everybody. Bye.
Bye-bye.